Hello all, welcome to your first lecture of college algebra. Uh, Today we are covering section 1.1, which is graphs and graphing utilities. This part it's about graphing utilities, maybe we are not covering this part because in this one, you need a calculator TI-84, and as I told you yesterday in my video, we are not going to use a TI-84 calculator in this class. We just learn how to graph. In section 1.1, we discuss graphing in general. Believe me, it's just kind of touching the graphs in this section, but later in this book, we do a lot of graphing. When we start with functions, we will learn a lot of different graphing. But here, it's just kind of review how you can do a graph and what is the graph of a function. The idea of graphing, actually it came in, I can tell you maybe in 16th century or early 17th century. A mathematician, which his name was Rene. I think here is also an E. Rene Descartes. We write like this. It's a French mathematician. He is a French mathematician, but we read this part as a Descartes. Name is not important here, but I want to give you an idea when geometry and algebra came together. Rene Descartes, in years of 1596 to 1650, which he was living on that era, he actually created a new branch of algebra, and that branch brought geometry together with algebra. He mixed both of them. That is the time that he created this two number line for us, a vertical number line and a horizontal number line together. He puts these two number lines together. He named the horizontal number line the x-axis and the vertical number line y-axis. The intersection between these two number lines, he marked it as a 0 and named it origin. Correct? When I'm telling you these are two number lines, it means on the right side of 0, you have definitely positive numbers, 1, 2, 3, 4. On the left side of 0, of course, you will see negative numbers, -1, -2, -3, -4. On the vertical number line, which is the y-axis, above the 0, the top portion, it's always positive numbers, 1, 2, 3. And below 0, we mark it as a negative numbers, -2, -3, -4. Now, what is interesting about this two number line, which nowadays we are calling a system, a coordinate system, or a rectangular coordinate system. This is the special name for this two number line, rectangular coordinate system, or even some people, they call it Cartesian, the system of Cartesian. It brought geometry very close to algebra. Look how. Let's start. Let's first talk a little bit about this system of rectangular coordinate system. I'll introduce a few things to you for the last time, and believe me, after this class, no one explain it again to you. You may remember, you may not. Let's talk a little bit about our system. Then we will talk a little bit about an equation in two variables. In this rectangular coordinate system, you see the system has 4 cells in it, which we call it not cell, actually 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, this is the right order. This quadrant is always 1. This quadrant is always 2. This quadrant is always 3. This quadrant is always 4. You cannot change it. No, I don't like, I want to do this. I'll name this one number 1, this one number 2. No, you cannot do that. It's standard. Everyone accepted this way. These are the order of the quadrants. Now, a few things. If you have a point on any of these quadrants, for example, this point, let's name it P. This point has a distance from the y-axis and also has a distance from the x-axis. For example, the coordinates of this point is 3, comma, let's say 2.5, or let's say 2, correct? 3, 2. For example, this coordinate is 2. We call this 2 number an order pair of x, y. The first number always shows how far your point is from the origin on the x-axis, and the second number shows how far your point from the origin is on the y-axis. Every single point, even in the real world, it has coordinates. We call this one coordinates. Great. And a coordinate is always an order pair of what? X, Y. Later, maybe some of you had already higher classes, like I saw 1 or 2 students that they already had calculus classes. You know that there is also another axis, X, Y, Z, which is 3-dimension or 3D. That's not the topic of discussion of this book. Later, maybe you see another axis too. But for time being, we only deal with the rectangular coordinate system, which has only 2 axes, the x-axis and the y-axis. Correct? Now, few things about this that I want to explain. Please remember this. You need it. And as I told you, no one else will repeat this stuff for you. Here is your x-axis. Here is your y-axis. If you have a point on quadrant 1, which has an x coordinate and will have a y coordinate. In quadrant 1, the value of x is always positive and the value of y is always positive. In quadrant 2, if you have a point xy, the value of x is negative, y is positive. Quadrant 3, if you have a point here xy, your x is negative, also your y is negative. Quadrant 4, if you have a point xy, an order pair, x is positive, y is negative. Maybe you say, oh, they're very, very basic stuff. Why I need this? I will show you why you need that. If immediately I give you a point like -2, 4, and I ask you, plot this point for me, where is negative point, for example, Q, -2 and 4, by looking to the order pair, immediately you should know, where is my point? Here, you see your x is negative, your y is positive. Okay, which quadrant x is negative, y is positive? Quadrant 2. If you know this, then graphing gets easy for you. You will not do a mistake. Here, xy, 1, 2, 3, 4, 5. On the y, 1, 2, 3, 4, 5, for example. On the x-axis, -1, -2, -3, -4, and on the y-axis here, -1, -2, -3, -4, and here your origin or 0. -2, 4 means on the x-axis, you go 2 units to the left to the -2. From here, you draw a line parallel to the y-axis going up because your y is positive. On the y-axis, you have +4. From +4, draw a line parallel to the x-axis. Wherever these two lines are meeting each other, that's your point Q, -2 and 4. Right? This is how you plot a point. This is why it's important for you to remember in which quadrant, which value is negative, which value is positive. Correct? I'm not focusing on plotting. I know all of you, you can plot a point on a rectangular coordinate system. It was just a review because it was in your book. We just discussed it. The other topic that I wanna here discuss with you or do a small kind of short lecture on it is graph of equations. Graph of equations. We know that a relation between two quantities. For example, I have one quantity y and I have another quantity x. A relation between two quantities always can be expressed by an equation, correct? If I put here an equal sign between y and x, it means this equation represents between two quantities. Let me explain it in a better language in your real life. I don't know up to this level how your math professors explain to you equations, but as I told you yesterday in my video, that in this book, we try to translate whatever we learn in algebra in our real life also. I told you two quantities. Y is a quantity, X is a quantity. The relation between these two quantities can be represented or expressed as an equation. What are these quantities can be? Let's do an example. I called y a quantity. For example, the y represents the cost of a TV, a television. X can represent maybe uh, years, how many years your TV is old, correct? For example, let me show you this one in an example for you. I don't want to do a word problem here for you, but I want to explain to you. I know it was a big question in my life. Can you believe I did majoring in engineering, then I did my master's in mathematics, but can you believe until I went to the faculty of engineering, to university, it was a big question for me. Every day I'm solving different equations and math classes, X, Y, X, Y. What is this X and Y? why I am solving this X and Y. What does it mean? Believe me, it was not, it was impossible for me, or actually it was difficult to learn. What does it mean? Because no one explained to us. What are the meanings of this X and Y, correct? But I'm trying to tell you that every equation that you deal in mathematics, it has a meaning in your real life. Look, I told you that here in this example, Y can be the cost of a TV. For example, right now we are in 2021. You go to a market, to Best Buy or to Target or to Walmart, and you buy a TV, a nice TV. I don't know how much is the real price. Let's say like $800, correct? After 3 years, 2022, 2023, 2024, the value of your TV is like around $600, correct? By having these two, points, believe me, I can write an equation for you that equation can talk or can give you an estimate what will be the cost of your TV after 10 years in 2030. How much will be the value of your TV that you bought today at $800? You see, I told you, X represents the year, Y can represent the cost. Not only cost and year. When you are using a variable, when you are talking about quantities, they can represent anything, correct? This is the real life with math. That's why I always say math is really beautiful. Whatever today we have, it's because of math, correct? Anyway, I don't want to go too far. You will study this part soon in few chapters. You will study, you will deal with these kind of problems, and I will show you how. But to come back to the actual lecture, when you have two quantities, X and Y, it can be the relation between these two quantities can be expressed by an equation. For example, Y equal to X plus 3. Y equal X squared minus 4. You see, all of them are equations, but you have two quantities, X and Y. The solution of an equation in two variables, which is Y and X, the solution for this equation always is an ordered pair of XY. Correct? When your equation has two variables, for example, this one, Y equal to X plus 3, if I want to solve this equation, I will get an ordered pair of what? XY. An equation in two variables can have infinite many solutions in this form that which is I'm writing right now for you. This equation can have infinite many solutions. How? For example, if I choose a table X and Y, and I choose some values for X, for example, when X is 0, when X is 1, when X is 2, how much is the value of Y? And if I plug the X value here in my equation, it gives me a value for Y. For example, let's plug in 0. Y equals 2 times 0 plus 3, which gives you 2 times 0 is 0, plus 3, Y equals 3, right? When x is 0, y is 3. You see, you got an order pair. When x is 0, y is 3. And this is one of the solutions of this equation, y equal to x plus 3, correct? Let me introduce a very important property here. Before, your teachers were telling you, when you want to graph an equation, use a table. Correct, totally correct. But what is this table actually? This is one of the important properties of the equations in two variable property. When the x coordinates, or let's say coordinate, is substituted for x, and the y coordinate substituted for y in the equation, we obtain a true statement. Sorry about my handwriting because I'm using just a Wacom, an electric pen. It's really difficult to write on a Wacom because the pen is sliding somehow on the Wacom. And anyway, my handwriting is really bad, but writing with the electric pen, it makes it worse. But I'm trying to write something for you. This property is actually the table of XY when we are using. If I give you an order pair, for example, 2, 4, and you have an equation y equal to x minus 3, is this order pair is the solution of this equation? How to know? Any order pair can be the solution of this equation? Yes or no? This property talks about that. Look, if then this property, it's telling us that if you plug in the coordinates of x and x and plug in the coordinates of y and y, like this, instead of y, I'll write 4 equals 2 times how much is x? Your x is 2 minus 3. Then 4 equals 2 times 2 gives you 4 minus 3. 4 equals 1, which is not, right? If you end up with the true statement, the order pair can, you call it the solution for your equation. But if you end up with a false statement like this, 4 is not equal to 1, then this order pair is not the solution of your equation. Using this property, using this idea, now you can graph any equation in plotting method. When you are using a table of XY like this, we call this method plotting method. And what you do You choose some values for x, you plug it in your equation, and you get values for y. And after that, you plot the points on your rectangular coordinate system. You connect the points, and it gives you a shape or the graph for the equation. Correct? Let's do, for example, at least one or two examples how to graph equations. And I'm telling you again, we are not done with graphing here. Plotting is not the only method. Later in this book, you will see we will do different types of graphing, correct? Only because it's the beginning of the book, I'll show you how you can use the plotting method to graph any equation. Let's start with a simple example. Example number 1. For example, they are asking you graph. And they give you an equation. Let's say y equals what? For example, x plus 2. As soon they ask you graph y equal x plus 2, what you do, make a table of xy. Here x, here y. Choose at least few points. Later we will discuss how many points for linear, how many points for quadratic, even more points for cube, but at least right now I don't want to talk about those. Choose few points, few values. You can choose for y, solve for x, or you can choose for x, solve for y. The easy way is choose values for x. For example, I'm choosing 0, 1, 2, and 3. Now, these values are the values of x, right? When x is 0, how much is y? To find that, what you do, write your equation, y equal x plus 2. Now, replace x or substitute the value of x in your equation. Then y equals, how much is x? X is 0 plus 2, y equals what? 2. Okay, when x is 0, y becomes how much? 2. Again, your equation, y equal x plus 2. Then y equals, how much is x this time? 1. 1 plus 2, y equals what? 3. Again, y equals x plus 2. When x is 2, then it will be y equals 2 plus 2, y equals 4. Same thing, y equals x plus 2, and y equals, when x is 3, this one will be 3 plus 2, y equals 5, correct? It means when x is 3, y is 5. After you are done with your table, draw your rectangular coordinate system, 2 lines perpendicular to each other, not like my graph, use a ruler or something. 1, 2, 3, 4, 5. -1, -2, -3, -4. Here on the y-axis, 1, 2, 3, 4, and 5. And on the negative side, of course, -1, -2, -3, -4, and here definitely 0. Start plotting one by one. Look, what are your order pair? The first order pair is when x is 0, y is 2. The second one, 1 and 3. The third one, 2 and 4. And the fifth one, 3 and 5. Try to plot these points. 0, 2. When x is 0, y is 2. It means your point is on the y-axis. When x is 1, y is 3. x1, y3. Look, I go up and I go 1 unit this way, 1, 3. When x is 2, y is 4, x2, y 4. When x is 3, y is 5. Here. And if you connect these 3 points with each other, you will end up with this straight line. And this line represents, or this line is the graph of y equal x plus 2. We call this method the plotting method. Correct? One more example. Example number 2. Let's say y equals absolute value of x. I need a table, xy. Let's at least this time use like 5, 6 points. Let's start from -2, -1, 0, 1, and 2. Let's go this time with the negative numbers too, correct? Okay, what you do, you plug in these numbers in your equation. Y equals, when x is -2, it means absolute value of -2. What is the absolute value of -2? The absolute value of any number is the number without sign. It means y equals 2. When x is -2, y becomes 2. Again, y equals absolute value of x. When x is -1, then this will be y equals absolute value of -1, which gives you what? 1. Absolute value of 0 gives you 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Correct? Let's graph it. X, y. When x is 0, y is 0 here. When x is -1, y 1. X -1, y 1. This point. When x is -2, y is +2. 2, -2, and 2. This point. -2 and 2. When x is 1, y is 1. x1, y1. This point. x2, y2. This point. And if you connect these points, you will end up with a V shape. It's like a V opening upward. And some of you that you had intermediate algebra, you know the graph of y equal absolute value of x is always a V shape upward or maybe downward. Correct? Later we will discuss when we start talking about functions. I'll go in detail with you. But right now, this is the graph of the equation that they are asking you to graph. Let's discuss now a little bit intercepts. I will explain this lecture. I don't want to put notes for you in a simple graph with a very simple line, XY. Let me draw a line in this system of coordinates. For example, this is your line L. There are 2 points, really important 2 points on this graph, which gives us a lot of information. What are those points? The point that your graph cross or intersect the x-axis, which is this green point, we call it the x-intercept of the graph. The point that graph intersect or cross the y-axis, we call it the y-intercept of the graph. Now, few things about x-intercept and y-intercept. When you're looking to the x-intercept of the graph, you see the x-intercept, actually your x coordinate has a value. For example, in this graph, maybe it's -3. But how much is your y? Is the point is on the x-axis? Because the point is on the x-axis, the value of your y coordinate is always 0. Remember this. Whenever you are looking for the x-intercept of a graph, the x-intercept of a graph or the coordinates of your x-intercept, you have a value for x and the value of y coordinates is always 0. Same thing, when you are looking for the y-intercept of a graph, the value of x coordinates will be always 0, but y has a value. This is the last time in this class we explained this to you. When you go to pre-calculus or other classes after this, your professor will not explain to you again what is x-intercept and y-intercept. Correct? Or how much is the value of x in the x-intercept, or how much is the value of y in the x-intercept. This is the last time that I am explaining to you. You have to know what is the meaning of x-intercept and y-intercept. Correct? If I do an example on this lecture, example, for example, find the x-intercept and y-intercept of y equal, let's say, 2x plus 1. They give you an equation and they are asking you to find the x-intercept of the equation, and they are asking you to find the y-intercept of this equation. How? Let's start with x-intercept. I explained to you that in x-intercept, x has always a value, but the value of y is always how much? 0. Having this in our mind, let's deal with it. If you know this much, it's really easy to find the x-intercept. Put your equation here, y equals to x plus 1. How much is the value of y and the x-intercept? 0. Replace this value here. Then 0 equals to x plus 1. Now you end up with a linear equation, correct? Everyone knows how to solve. Or maybe in the next topic, we will discuss this, how you can solve a linear in 1.2. I'll explain to you how you can solve a linear equation. If I solve this equation, 2x plus 1 equals 0, I will subtract 1 from both sides. Then 2x equals -1. I will divide both sides by 2. Then x equals -1/2. Okay, now what is the x-intercept of the graph? The x-intercept of the graph is -1/2, comma. How much is the value of y? The value of y is 0. To find the y-intercept, again, your equation y equal to x plus 1. I know in the y-intercept, the value of x is 0 and y has the value. Then plug in 0 in your equation instead of x. Y equals 2 times 0 plus 1. It means y equals 0 plus 1. It means y equal what? then your y-intercept of the graph will be 0, what? This is how easy you can find the x-intercept and y-intercept of a graph. Maybe I don't ask you right now to find these, but I did an example. But after I teach you how to solve a linear equation, when we move to functions and we talk about linear functions, there we discuss again how to find the x-intercept, how to find the y-intercept, not only for linear functions, for quadratic, for cube, for other functions, how you find the x-intercept and y-intercept, it's the same idea. You have to remember, if I'm looking for the x-intercept, always the value of y is 0. And y-intercept, always the value of x is 0, correct? This was all about section 1.1. I'll stop the lecture here and see you all in section 1.2.